This will be the final video in our first lesson about conditional statements. This video will talk about what a biconditional statement is. Let's check it out. A biconditional statement is a single true statement that combines a true conditional with its true converse. Now notice that everything has to be true. We can't have one hypothesis that leads to a conclusion that's false. Everything about the statement has to be true. Let's check it out. When we build a biconditional, we're going to join the two parts of the conditional with the phrase if and only if. This is a dead giveaway that we're working with a biconditional statement. This is a fairly long phrase, and a lot of people want an abbreviation for it, and the agreed upon abbreviation for if and only if is IFF. That's not a misspelling of the word if, it's the abbreviated version of the phrase if and only if. Let's check out a couple of examples. Example 1 here says the conditional is if an angle is right, looks like I left out a comma, then it has a measure of 90 degrees. Well, think about that for a second. If an angle is right, then it has a measure of 90 degrees. Is that a true statement? Yes. All right angles have a measure of 90 degrees. Okay, now let's take that conditional and turn it into a converse. Remember, a converse takes the original conditional and flips the hypothesis and conclusion. So the new statement would read, if, let's go grab the conclusion. If an angle measures 90 degrees, then, now go back to the conditional and look at the hypothesis. The original hypothesis is an angle is right. So let's bring it down. If an angle measures 90 degrees, then it is right. Okay, let's think about the validity of that statement. Let's read it through. If an angle measures 90 degrees, then it's right. Is that true? If an angle measures 90 degrees, is it a right angle? Yes. Okay, so this statement can be read forwards and backwards. It can be read as its original conditional, and it can be read as its converse, and they're both true. Since that's the case, we can claim this can be a biconditional statement. To build a biconditional statement, let's go back to the conditional and rebuild it using the phrase if and only if. To do that, start with the original hypothesis. An angle is right. Replace the phrase then with the phrase if and only if. And you can use the abbreviation there if you want to. If and only if, and then finish the sentence with the original conclusion. An angle is right if and only if the original conclusion is it has a measure of 90 degrees. Okay, let's read this conditional and see if it makes sense. An angle is right if and only if it measures 90 degrees. Or we could turn this around and say, if an angle measures 90 degrees if and only if it is right. A biconditional can be read forwards and backwards. You can rearrange the converse and conditional, and they are both still true. Well, of course, this is geometry, and of course that means we need a new symbol. The mathematical symbol for a biconditional statement is a P and a Q with a double-headed arrow in between. This signals that you can read the statement forward or backwards, and it's still a true statement. Let's check it out again. My next example's conditional is, if a figure is a square, then it's a quadrilateral. Okay, let's think about a square. A square is a four-sided shape where all the angles are 90 degrees and all the sides are equal. Let's think about a quadrilateral. A quadrilateral is the generalization of any four-sided shape. So if a figure is a square, then it is a quadrilateral. Yes, that's true, because a square has four sides. Okay, now let's build the converse. Remember, the converse reverses the order of the conclusion and the hypothesis. So if a figure is a quadrilateral, then go back to the original statement and get the hypothesis. If a figure is a quadrilateral, then the figure is a square. Then it is a square. Okay, let's think through that statement. If a figure is a quadrilateral, does it have to be a square? If a figure is a quadrilateral, then it is a square. Well, that's not a tight argument right there. If you just tell me something's a quadrilateral, maybe it's a rectangle, maybe it's a rhombus, maybe it's a trapezoid, maybe it's a kite, maybe it's some wonky quadrilateral. So this is not a true statement. Just because something's a quadrilateral doesn't mean it has to be a square. So we've hit a snag. Okay, we cannot build a biconditional statement here. If I can't read the conditional and converse as two separate true statements, then I cannot build a biconditional. Okay, pause here and give yourself a checkup. There's an independent practice at IXL I6. This time you're going to 80 to get up to the higher level thinking. Happy studying, and you are finished with lesson 1 of this unit.